think everybody gets caught up on the fanciest algorithm, right? Like, people always talk about deep learning. You hear about all these things in AI that can replicate a human or whatnot. But oftentimes, especially if you're working in something that's dealing more with the business and like the higher ups, you want something like a decision tree or something random, like a random forest, something that's much more simple can work better.
Hi, welcome to another edition of Mathematicians. My name is May and I'm joined by the awesome Greg Tam, who is a principal engineer data science at Smart. He has a background in statistics. He also did an advanced degree at Harvard in statistics. And then he's worked in the fraud detection industry as a data science for a couple of years before recently going into the media side of things as a principal engineer of data science at Smart specifically. So welcome to the show, Greg. How are you doing today?
Thanks for having me. It's
awesome.
Great. Cold day in New York, but...
I know, right? Well, it's wonderful to have you. Really want to sort of, get your insight on the industry, but perhaps start by sort of telling us what your journey's been like, getting into data science, from school, what led you to choose those courses, how you decided it was a career, your first role to where you are currently.
Yeah, sure thing. So I've always been a mathy type of person, right? Ever since I was a kid, I just always loved math. I was a type of kid in high school to do math competitions and all that. Funny enough, I come from a family of doctors, so that was kind of the expectation to me when I first started university. And I did pre-med, and I hated it first year. So that first year I did pre-med and took a math course, and that was in probability, and loved it. And I decided I'm going to do this instead. I'm not going to follow the medicine path. And then so that led me into my journey in statistics. I did my undergrad at McGill University, then went to Harvard. And it was there where I discovered data science. So at that time, data science didn't really exist. It existed in some capacity, but it wasn't like there were no MOOCs, there were no master's degree programs. Right. It was very new, but there was a class in data science at Harvard that I took, and I really enjoyed it. So then at that point, I was actually thinking of going into finance. Did a whole bunch of finance interviews. Didn't think that was really a fit for me, and I ended up doing an internship in data science in the Bay Area that summer, between my first and second year in grad school, and fell in love with it, and just knew that that's what I was going to do afterwards.
Wow, amazing! So, with your first opportunity, what was that experience like? Maybe tell us a little bit more about your role as a data scientist in terms of the value you added to that company.
So. Specifically at the internship, you mean?
Yeah. Well, no, it's your first role after the internship. So
I see.
You went into sort of fraud detection as a data scientist, which is a more consulting-driven type of role.
Yeah. So that first role was at a company called Pivotal, and Pivotal does basically data and software consulting. Right. So they actually help build Gmail, Uber, Airbnb, Twitter. Yeah, a lot of big name companies in the Bay Area.
Because it's a consultancy, it makes sense. Okay, I get it. Understood.
Exactly.
Understood.
Yeah. So the data science arm, we had teams all over, but I was based here in New York, so that was mostly dealing with banks. And it's really just helping a bank leverage its data to solve some business problem. Right. Most of it was fraud, credit card fraud. There's also a lot of insurance use cases in insurance companies, where you're trying to find probability of a claim, stuff like that.
Right. So how did you decide you kind of wanted to veer out of fraud detection into more sort of the ad space, which is, especially being in media as well, what was the draw there? And how does your role specifically differ? Because it's slightly different title, but how does it differ in terms of your day-to-day and the value you add in that space?
Yeah, so I actually was at one company in between. So after Pivotal, I left to go to a company called Threat Metrics, which does fraud detection specifically. Yeah. And so basically what they do is they put their service into company, like our clients' web pages, their clients' web pages. I don't work there anymore. So, when you log into a bank account, say from a public computer, and you get that text message saying, "Oh, we want to verify this is you, we'll send you a code." Yes. So that was us telling the client that this person is fishy. Let's send them a code to make sure. Right. Or if they're really fishy, just reject them altogether. Yeah, and then so I was there for 2 years. I was at Pivotal for 2 years, and by the end of it, I was kind of sick of fraud. It's just so tight with its regulations that you can't really use the full breadth of data science technologies and everything that's available to you.
But it must have been great foundation as data scientists because a ton of data and things to work through. So how does your role currently differ from all of that? What are you doing that's different and interesting to you?
Yeah, so again, I work at NBC Universal, and we do, we're on a team called AdSmart. And what AdSmart does is it's really trying to place ads intelligently. These are television ads.
Right.
So there are three types. There's linear TV, which is just regular TV that runs on its schedule. Mm-hmm. There's DVR, which is when you're, sorry, not DVR, it's streaming.
Right.
Wait, no. So there's linear, I should know this. There's linear, there's the one that you, video on demand, that's what it is. So video on demand when you're watching something that already occurred before.
Okay.
And then, so you can't actually skip those ads, right?
Oh, right.
So those are set to the household. And then there's streaming, which is on an individual device like your phone or your laptop. Right. So then, and it's slightly different for each of them because linear, which would be done on a nationwide scale, you have to kind of build those or look at those ads and see which ones are going to work best across everybody.
Oh, isn't that quite difficult, right?
Yeah, and then video on demand would be on a household level, and then streaming is on an individual level.
Ah, very interesting. So do you work across all three silos then, and you're trying to optimize accordingly for each demographic?
Yeah, so a lot of that has to do with placing ads based off how much companies are willing to bid on the ad spots, right? Like Super Bowl ads are going to be really expensive. Wednesday at 2 a.m. is not going to be that expensive.
Okay. Understood. And so in your current role, what sort of technologies and languages are you working with, and what would a person need to sort of know to succeed in a role like yours? What are the key skills you would define?
Mm-hmm. Yeah, so we're mostly a Python shop, so that's really important. We also use AWS, so big data technologies, working on Spark and S3. And, of course, there's a lot of machine learning that goes into it.
Absolutely. Do you think having a statistics background is necessary to work in your role, for example?
I think you need a strong grounding in it. And I think typically most data scientists come from some kind of statistics, computer science, or hard science background.
Exactly, hard science.
You have to be very quantitatively driven. Have a quantitative mindset, and also just have a lot of experience with working with data.
Okay. With that said, what is your sort of thoughts on the fact that we're now actually getting, advanced degree courses in data science, and typically employers are, they're looking for those quantitative hard sciences like statistics, operations research, mathematics. With this move to, advanced data science becoming more popular, where is the place for MOOCs, the place for self-study on your own, or, should I go back and do an advanced degree in statistics, or should I do one in this newer data science that's coming up? What's going to be the best sort of route to optimize for getting into data scientists as a career if, I'm trying to break through? What would you suggest, and what do you think about those sort of statistics and more, newer sort of data science advanced courses as well?
I think it really depends on your background. For example, it's really difficult if you don't have any experience with any type of mathematics post high school, right? Because any type
So I couldn't do it then.
Yeah, well, any type of program builds on a whole bunch of fundamental math principles, right? You have linear algebra, and you have like linear algebra, probability, and those are really the core foundation of what everything is being built on top of. And if you don't have that baseline, then it's very difficult. And I know, for example, a lot of these boot camps, right? Like I think Galvanize, they actually require you can't just pay to get in. It's an application that you need to submit, and they need to approve you. Right, so they need to look at your resume, and see what you've done before. Say you come from a chemistry or physics degree, and then say, okay, this person can learn from what we're teaching, because they're not teaching you everything from scratch. They're teaching you assuming you know some level of mathematics.
Right. So, if you're placed with a candidate that, has basically taught themselves data science and they're showcasing their GitHub projects, or someone that, has gone on several MOOCs or someone that has an advanced degree in the hard science, who looks most appealing to you in that situation to join a data science team?
So I don't think it's impossible to self-study. It's certainly possible. The hard thing is probably to actually convince someone that you're good enough.
Right.
And I think something like doing a personal project and putting that on your GitHub would really help, because then it gives someone access to see. Right. For instance, I actually had someone who I interviewed who was coming from a bachelor's in criminology, but he had Python and SQL on his resume. I interviewed him and I gave him the most basic question that you would learn day one of SQL, and he couldn't answer it.
Oh, wow.
So
wow.
That's the thing. Okay. If he has a degree, or if it's comparing him to someone who has a degree in something, I doubt that would have happened. Sure. It's like a degree in statistics or computer science. I doubt that something like that would happen. It
kind of gives you the context that you have some foundational basics. Exactly. Like you know what linear algebra, you can solve, simple probability problems because you've done a statistics degree. So what's your opinion on doing a statistics degree as opposed to doing an advanced data science degree? Which would you opt for in this new world that we're living in 2019 going forward? What's the better route to go? Is it better just to stick to that quantitative, classic statistics advanced degree, or do the newer advanced data science degree?
It really depends. For instance, I think statistics would really help you if you're trying to go into another discipline other than data science. Not that getting a master's in data science would preclude you from that. I think also that if you want to be a researcher, someone with a PhD, you pretty much have to get one of those hard sciences. Right. I know, for instance, so my brother is doing a master's in data science at UBC, and that's in Vancouver, Canada. Right. And I know that program explicitly says if you're looking to get a PhD, don't do this program. Right. This program is built to send you into industry. Right.
Okay. So it's almost like an applied, form of a statistics program specifically geared at a data science career. So in your opinion, you actually think they are beneficial, even though they're quite new and we're still testing, the efficacy of it. You think it's actually quite useful course, potentially for industry specifically.
Yeah. And I did a statistics program. And when I started working as a data science, there were still a lot of things that I had to learn. Right. You have to learn on the job. And then, like I said before, my brother's doing a master's in data science, and I looked at his curriculum, and there was a lot of things that I had to learn on the job that I see that are being taught in that curriculum.
Okay, so it sounds like it's useful from an industrial perspective.
Yeah. Plus, certainly. Plus, a lot of these programs aren't just being spun out of thin air. They're typically interdisciplinary, so there'll be combinations or collaborations with the statistics department or the computer science department, right? Merging together, combining resources, sharing professors from both.
I see. Very interesting. What do you think is the biggest misconception about working in machine learning or generally data science as a career from your experience?
I think everybody gets caught up on the fanciest algorithm, right? Like, people always talk about deep learning. You hear about all these things in AI that can replicate a human or whatnot. But oftentimes, especially if you're working in something that's dealing more with the business and like the higher ups, you want something like a decision tree or something random, like a random forest, something that's much more simple can work better. I know also people like to look on Kaggle a lot and try to optimize and get the maximum score. But explainability is really important in business.
Describe, for those that are not familiar with it, what does explainability mean, and how do you sort of, achieve that successfully in business?
Yeah. So I'll lead back to my own experience working in fraud, right? You maybe you can predict if someone's going to be fraudulent 99% of the time and do it really well. But if you can't say why they're fraudulent, then it's not useful. Because you can't just reject them because,
I think they're fraudulent.
This algorithm said you're going to likely be fraud. You can't do that.
Okay.
And so that's the difficulty.
Right.
Similarly, if you're working, say, in an industry where you're selling something or you're trying to get some insight on how, some kind of metric on how well the business is doing, you need to have some kind of information on what is affecting that so you can change it.
You mentioned previously you interviewed someone and their data skills from an SQL perspective was quite weak, and it kind of reminded me of working with a hiring manager recently. And, for that particular, I think it was a very product-driven data science role, there was a big need for part of the skill set to be that they had very strong data skills and not just like basic SQL. They were quite advanced in the sense that they could deal with nested statements and complex table joins. Now, I mean, how important is, what if I am in a team where, we have data engineers that can get the data, clean it, and do all that stuff for us in terms of extraction? How important is that SQL skill set in the general scope of trying to get into data science? Like, what's your perspective on that?
It's still really important. People really always get caught up in the whole machine learning algorithm aspect of it. Supervised learning, unsupervised learning. Right. But I would say 80% of the work that we do is cleaning data. Cleaning data, preparing data. So that is
true, because I spoke to someone recently and they were like, that fact isn't true. Someone said it and they just held on to it forever.
Maybe it depends on your role, right. but I think, and maybe not necessarily cleaning data, but some kind of preparation of data, right? Like
Absolutely.
Feature creation is huge, right? How do you manipulate your data?
Right.
Because typically it'll come from multiple sources, right? You can take it from the phone log data, you can take it from weblog, you can take it from, any type of interactions they do anywhere.
Right.
Anything that you can capture, you can have as data, even external data, you can merge in together, and you somehow need some business insighting to create a feature for that.
Right. Interesting. So Greg, there was a recent opinion piece in the LA Times that spoke about how, high schools need to catch up with where things are going in the real world, in the sense that the math they're teaching is very outdated and they should move away from that to more sort of maths that's actually specifically useful in the context of data science. Because, there's this view potentially that data science isn't just going to be something a few people train for, but we actually are going to, possibly need everyone in every role to have some data-driven capabilities. What's your view on that? Is it important for us to stick to what we have done and keep those fundamentals in place anyway? Or should we be moving more to an evolved world where we're trying to gear people up to be more data scientists and the math is changing in the syllabus to reflect that? What do you think?
I think starting that in high school is a bit too soon.
Okay.
Again, every element of mathematics and data science all builds on top of each other, right? You need to have that strong foundation, and then from that you build up and build up. Right. You can't start off showing, like a 12-year-old machine learning. It's I mean, maybe you can dumb it down to some level, but it's very difficult to do that.
Yeah.
And I'm not sure how the curriculum works here. I grew up in Canada, but judging from that, I don't think it's. I think it's good maybe to show kids that this is something you can do with math, because the way math is taught is just, here are some numbers, here are some sets of procedures that you can do. And kids always think, oh, what can you do with math? It's just,
Yeah, there's this cartoon that's going around on social media where it shows in the past, everyone thought people that studied maths were geeks, but now the math person is the coolest person in the party because everyone wants to be a data scientist. So it's like...
I wouldn't go that far.
I mean, depending on how you want to see it. But I think the key thing to draw from what you said is demonstrating the application of what they're learning and, tying that back to real life. And it doesn't need to be change necessarily to data science, but just being able to demonstrate the impact of what they're learning is the key sort of metric to take out from that. So that's fine.
And even in my own experience, right, as I said before, like I was planning to be a doctor when I came out of high school because, but I loved math so much more, but I didn't know what I could do with it. Right. And part of that, I think, is because there's not that transparency, and there's a little bit of misinformation about what you can do with it.
Yeah. Oh, maybe we need an applied math program or something of that sort. Okay, interesting. How do you see the data science role evolving? Like, there's talk that, we're needing more and more machine learning engineers to actually productionize these models. And, for every data scientist, we need 4 data engineers. There's different sort of statistics flying around, but the role of the data scientist itself is blurry, particularly even in a startup environment. Yeah. How do you see that role evolving? What do you think the key differences are? Like, if I wanted to pick a career route, should I be a data scientist or should I be a machine learning engineer? What are the how is this going to evolve, and how does it matter from a career perspective?
I think it's, again, data science roles are really nebulous. Companies see that buzzword, they put a job ad for it, they don't really know what they want from it. And I've seen so many different variations of it, and asking all sorts of different technologies. And I know a lot of, especially if they're starting a team from scratch, like they'll have an HR rep who just doesn't know what's what's really
that can be interesting.
What they really should expect. But one thing I think I see it going as is it's starting to split off into different subfields, similar to software engineering, right? Software engineering you have full stack developer, you have some kind of web developer. I don't know all the different terms. QA tester. So I think data science is going to start to do that, and I think it is in some sense. You have people who are NLP specialists, people who are just machine learning specialists, and also deep learning. So perhaps moving away from just the jack of all trades, that's a generalist in all areas, but really, because you're right, there are roles that are specifically high demand for an NLP specific machine learning engineer is going to be the best fit for that, and deep learning accordingly. So that totally makes sense. There's also the split between if you have a PhD or not, right? Because PhDs are typically doing more research type roles. It's very different.
Yeah, totally agree. Great insight. Do you have any sort of recommendations for aspiring data scientists and machine learning engineers more generally, people looking to get into the industry, or people even looking to switch industries? Maybe they come from a physicist background or something. Just general recommendations from a career perspective. What are your thoughts?
So again, I guess it depends on your background. So I think, one, it's important to have a very strong foundation in mathematics. Two, there's also and this is the less talked about one, I would say, is the actual business insight part, right? You can't just build a model and just keep it in place. You have to be able to translate your results and communicate them to people.
Right. Awesome. So you've really sort of focused on the math side of things as well as the more, and I think the business insight aspect also touches on the communication and, being able to probably do feature engineering in context of the area that you're working in and things like that as well.
Yeah, in order to actually have an impact on your business, you need to be able to communicate your results and show what is doing what.
Okay, awesome. So thank you very much for coming on the show, Greg. It's been wonderful having you. Until the next edition of Mathemagicians, we'll see you later. Please do drop your comments below, like, share. Until we see you again, have a great day.